In this lab you will launch a projectile so that its initial velocity is purely horizontal. Knowing the vertical distance it is to fall, its initial velocity, and the acceleration due to gravity, we can derive an equation for the horizontal distance the projectile will travel before striking the floor. Remember that for all calculations, you must write the general equation first and then fill in the numbers. Include all units in all steps. As you can see in the drawing, you will roll a ball down the ramp and across the level countertop. The ball will then leave the countertop with an initial velocity and travel in freefall until it strikes the floor. Because the countertop is level, the ball will enter freefall horizontally. To find the initial horizontal velocity of the ball, we will measure the velocity of the ball as it rolls across the countertop. Place the ball on the ramp. Release the ball and use the stopwatch to measure the time required for the ball to roll from the bottom of the ramp to the edge of the countertop. For accurate timing, sweep your hand holding the stopwatch with the motion of ball to anticipate when it reaches the end of the ramp and when it crosses over the end of the countertop. Do not let the ball hit the floor yet. Repeat this measurement 6 times and with your values, calculate the average time. Measure the distance from the bottom of the ramp to the edge of the countertop where the ball will roll off the countertop and enter free fall. Record the distance from the bottom of the ramp to the edge of the countertop. With your distance and average time values, calculate the speed of the ball across the countertop and record the value. Then, measure the vertical distance that the ball will fall from the countertop to the floor. This is the height of the countertop. Using your freefall equations and data, calculate the time of flight for the ball from the edge of the countertop to the floor. Next, find the horizontal distance the ball will travel from the time it leaves the countertop until it strikes the floor. Now that we have done all of the calculations for the theoretical range of the ball, you must find the experimental range. Release the ball from the same height on the ramp as before. Let the ball roll off the edge of the countertop and hit the floor. Measure the actual horizontal range of the ball as shown in class from the end of the plumb line to the point where the ball hits the floor. This distance is your experimental range. With your tested experimental range value, and your calculated theoretical value, determine the percentage difference between the two values.